Hi, and welcome to episode 2 of our series Prototyping versus Production. Today we're taking a deep dive into DFM and how to optimize your design for production. So without any further ado, let's get started. Simplifying geometry in your design is crucial for making the manufacturing process easier, faster, and more cost-effective. First of all, avoid complex shapes. And this because complex shapes often require specialized tooling and multiple manufacturing steps. This increases production time and cost, and they can also lead to higher rates of defects due to difficulty in maintaining precision during machining. In order to fix that, what you can do, you can segment complex design. So if a complex shape is necessary, consider breaking it down into simpler modular components that can easily be assembled. Sharp corners are prone to stress concentrations, which can then lead to material failure. Additionally, sharp corners are harder to machine or mold, often requires lower speeds and more frequent tool changes. In order to fix this, what we can do, we can use fillets and radii, so incorporate rounded edges wherever possible. For example, instead of a 90-degree internal corner, use a corner with a radius of 1 to 2 mm to reduce the stress concentration and ease manufacturing. Don't forget that the minimum radius also varies depending on the material and depth of the feature, so plan accordingly. Use common radius sizes to streamline the manufacturing process. This minimizes the need for custom tools and simplifies programming for CNC machines. Design parts with consistent wall thickness, ideally between 2 to 4 mm, depending on the material and manufacturing process. It's very important also to limit tight tolerances. Tight tolerances require more precise manufacturing process, which increase production costs and time. So in order to fix this, what you can do is you can define critical areas. So identify and apply tolerances only to critical areas where they're essential for parts function. For example, a hole diameter for a press-fit bearing might require tight tolerances, while the other dimension can be more lenient. Where precision is less critical, use industry-standard tolerances like plus or minus 0.1 mm for general dimensions. This reduces the need for expensive precision machining and simplifies quality control. Removing tighter tolerances also improves the repeatability of the part and allows us to cut costs. Part reduction involves minimizing the number of individual components in a product. This approach simplifies the design, reduces manufacturing and assembly costs, and can enhance the overall reliability of the product. It's very important to combine functions, so make sure to design components to perform multiple functions, and this helps us reduce the total number of parts that are needed. Think about multifunctional components, so identify opportunities where a single part can serve multiple purposes. For example, a structural bracket might also serve as a mounting point for other components. Design parts that can be used in multiple products or configurations. This standardization reduces the variety of parts needed. Create modules that can be combined in different ways to create various products. For example, use a standard motor module that can be integrated into different product lines. Design standardized interfaces for modules to ensure they can be easily connected or assembled in different configurations. Review each part to determine if it is essential to product's functionality, and if not, remove or combine non-essential parts. Perform a thorough analysis of each component's function. Remove parts that do not significantly contribute to the product's performance or user experience. Think about streamlining the design. Simplify the design by integrating smaller components into larger assemblies or using advanced manufacturing techniques to create complex features within single parts. Well, that's it for today's video. If you liked it, don't forget to like it and subscribe, and I'll see you in the next episode.